Today we're going to be talking about reducing radicals, specifically square root radicals. A square root is represented by kind of this symbol with a number inside of it. And if it's a special number, if we put this in a calculator, we will get a whole number. It's like the square root of 25, and many of you might know this, equals 5. The square root of, for instance, 81 equals 9. But what happens if we have the square root of 50? Now, if we put that in the calculator, you're going to get some long decimal that goes on forever. This is what we call an irrational number, because it goes on forever. But we want to be able to reduce that in a special way. And one of the ways we do that is to find perfect squares that are factors of this to see if there are any. Some we can't reduce at all. Like if we have the square root of 19, there's no number, we can't reduce it. We would leave it as a square root of 19 to keep it a more perfect number. But how we would assess like the square root of 50, we can rewrite this. We can rewrite this as, and we want to use this bank of perfect squares right now. 2 times 2 is 4, 3 times 3 is 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11, 12, and 13 squared are here. If any of these numbers go into 50, I want to use them. And only that bank of numbers. So as you can see, I cannot use 10 because 10's not here. So typically what I like to do is I go in reverse order. I want to find the smallest number, or the largest number that's smaller than 50. So I'm going to start with 49. I know 49 does not go into 50. 36 does not go into 50, but guess what? 25 does, and it goes in twice. So I can rewrite this as square root of 25 times the square root of 2. Because we know 25 times 2 is 50. Now we can readjust this, and we can say that the square root of 25 is 5, and we keep it times the square root of 2. This is the best answer we can have for the square root of 50. We want to be able to reduce this radical. It's like reducing the number 3/9 and changing it to 1/3. It's like reducing fractions. It just helps us overall evaluating our numbers and being able to use them. So when we're doing this, we always want to look back at these numbers. So I think I started off with 4 numbers. Square root of 28, the square root of 48, square root of 80, and the square root of 72. Now looking at 28, again, the smaller the numbers are easier to work with. I'm going to start with, again, the largest number that's smaller than 28 is 25. It doesn't work. Does 16 go into 28 evenly? If we divided it out, it'd be like 1.7 maybe. Does 9 go into 28? No, that's, I think, 3.1. Right? And it goes on forever. But if we divide this by 4, 4 does go into 28. So we can rewrite this as the square root of 4 times the square root of 7. 4 times 7 is 28. Now we know the square root of 4 is 2 times the square root of 7. It's going to be very easy to kind of mix up what goes first, the 4 or the 7. Always put that perfect square, one of these numbers, first, no matter what. Let's look at 48. 36 doesn't work. 25 times 2 is 50, too much. But if I use 16, 48 divided by 16 is 3. We can rewrite this as a square root of 16 times the square root of 3. We know the square root of 16, or maybe you do, maybe you don't, but I know it, that it's 4. We end up with 4 radical 3. times the square root of 3. Also remember, these are multiplied together. It's 4 times that number, that square root. Now some of you might have said, well, how come we can't use 4? You could, but it would not be completely reduced. We would end up with kind of like the square root of 4 times the square root of 12, and we'd end up with this answer. Now again, that's not wrong, but guess what? There's still enough, we can still take 4 into 12 and we can rewrite it like this. Now remember, these numbers are all multiplied together. 2 times 2 on the outside times the square root of 3 still gives me 4 times the square root of 3. Just took a little bit longer, but you want to reevaluate that square root just in case. Think about square root of 80. If I look at this, 81's too big, 64 doesn't work, 49 doesn't work, 36, no, 25, no. But again, 16 works. And it works, goes into 80 5 times. Square root of 16 is 4 times the square root of 5. The last one, 72. Again, we want to think about the largest one. So 64 doesn't work, 49 doesn't work, 36 does work. 36 goes into 72 twice. This is another one, maybe you'd want to use 9 and 8, but then again you'd have to reduce the square root of 8 again. The square root of 36 is 6, and it ends up being 6 times the square root of 2. Now some of us might not have our multiplication and division facts square. That's when you're going to have to take your time and divide them out. Take these numbers and divide them by these numbers here to see which one comes out where it is a factor. And you write them as 2 factors and square roots and then reduce them. There's 4 more problems at the end in your notes. Okay, the square root of 90, the square root of 300, the square root of 32, and the square root of 54. Your job is to finish these up before you turn your notes in. Okay. So these numbers at the bottom, these must be completed. This is your practice. Square root of 90, square root of 300, square root of 32, square root of 54. All of them can be reduced. Just no tricks. See you next time.